I, on behalf of DIgSILENT Technologies, welcome you all for our FDP workshop program on power system analysis using DIgSILENT PowerFactory software. I'm application engineer, power system division at DIgSILENT Technologies, and responsible for promotion of DIgSILENT PowerFactory software in India. DIgSILENT, established in 2004, is a research-based company engaged in promoting path-breaking software solutions primarily for the education sector, thereby helping the institutes to enhance their infrastructure and provide best possible software solutions. We are sole authorized distributor of DIgSILENT PowerFactory for research and education software in India. Today's agenda would be like, firstly, I will be showing you 12 to 15 PowerPoint slides first. This will take around 10 to 15 minutes, in which I will describe about the available PowerFactory features and details. Secondly, I will be showcasing the live demo on DIgSILENT PowerFactory with few examples. This will be of around 40 to 50 minutes. And after that, in the second session, we will be having the hands-on on DIgSILENT PowerFactory. After the end of the session, we will be having question and answer round for around 50 to 20 minutes. We will keep all your mics on muted mode just to avoid sound disturbance. After the end of session, we will try to answer all your questions one by one. So once again, welcome you all for PowerFactory design analysis using DIgSILENT PowerFactory software. And we believe that session would be informative. And after the session, please don't forget to send us your feedback and suggestions by email so that we can work upon them and improve it better. So here we go. So DIgSILENT stands for Digital Simulator for Electrical Networks. DIgSILENT was the first power system analysis software. It has set trends in power system modeling, analysis, and simulation for more than 25 years. DIgSILENT PowerFactory is a leading power system analysis software for applications in generation, transmission, distribution, and industrial systems. PowerFactory 17, DIgSILENT presents a further step towards seamless integration of functionality and data management with multi-user environment. So everyone may have one question, that why DIgSILENT? So DIgSILENT comes with an integrated graphical one-line interface. It consists of one-line diagram including drawing functions, gating capabilities, and various static and dynamic calculation features. PowerFactory offers most economical solutions as data handling, modeling capabilities, and the overall functionality replace of other software systems, thereby minimizing project execution cost and training requirement. The all-in-one PowerFactory solutions promote highly optimized workflow. PowerFactory is easy to use and caters for all standard power system analysis needs, including high-end applications in new technologies such as wind power and distributed generations, and handling of very large power system. So what's new in this 17th version? So PowerFactory 17 releases a portfolio of new capabilities and features for improved result. Visualization and graphical representation is added. The new version comes with completely redesigned look, making the handling easier with accurate workflow. The new electrical models and extensions added to the existing model suite. Moreover, it integrates with a variety of new models and will provide an improved calculation performance. Its rich analysis and modeling capabilities perfectly suited for network planning and operation studies, from small microgrids over distribution network with distributed generation to large transmission systems, new HVDC technologies, and renewable generation to account. Power transmission. Nowadays, transmission grid is undergoing a major change to reliably store increasing amount of non-dispatchable resource while maintaining efficiency and system cost. PowerFactory offers a complete suite of functions for studying large interconnected power systems and addressing these emerging needs. Its simulation algorithm can be applied to any AC or DC network topology, support the simulation of new technologies such as converter-based power generations, FACTS, voltage source converter, VSC, and a lot more. PowerFactory is also perfectly suited to transmission system operation planning. It integrates a comprehensive set of tools to support automatic and parallel grid safety analysis and outage planning. And Now, power distribution. In power distribution, different phasing technologies such as single wire earth return, two-phase, biphase, or classical three-phase systems have created the need for multi-phase distribution system modeling. For this, PowerFactory provides comprehensive modeling features for studying all kinds of electrical network with different phasing technologies such as mesh or radial topology and railway supply systems to reduce network imbalance, improved quality of supply, and optimized distribution network. PowerFactory offers a large variety of functions such as multi-phase load flow analysis, short circuit analysis, and multiple fault analysis, harmonic analysis, quasi-dynamic simulations, and a lot more. Other standard features include the modeling of virtual power plants, voltage drop analysis, daily load and generation profiles, and easy-to-use protection coordination. Now, industrial systems. Industrial power system supplying power to different industries with high power quality and precision to ensure continuity of production and safety. So for this, PowerFactory offers the vast set of functionality perfectly suited to the industrial user needs. In addition, PowerFactory provides calculation accuracy, appropriate standards, clearly presented results, and the comprehensive and user-friendly interface. PowerFactory comes with high precision load flow algorithm, flexible short circuit calculation features, four-wire modeling, protection system modeling, harmonic analysis, and filter design options. Power generation. So highly optimized expertise is available in many fields of electrical engineering, applicable to liberalized power market to the latest development in power generations technologies. Reliability and efficiency are the mandatory properties of a power plant, as it represents the core of any power system. Power Factory offers the various tools for analyzing all aspects of their electrical components. Distributed generation. Generation and distribution levels comes with new challenges for distribution planning engineer due to reverse power flows, voltage drops, and extreme variation in equipment loading. So DIgSILENT offers various generation technologies such as synchronous and asynchronous conjugation units, PV cells, wind turbines, fuel cells, and micro turbines. Typical studies include steady state and dynamic analysis. Power Factory is the ideal tool for analyzing the impact of distributed generation on network. It has system analysis functions such as voltage drop calculations, unbalanced network, load flow generation modeling, selectivity analysis. DIgSILENT comes with highly modern analysis tool featuring dynamic simulation functions and reliability analysis. Renewables. Complex study for the integration of renewable generation into distribution, transmission, and industrial network are one of the key issues of nowadays network planning and analysis. Power Factory combines extensive modeling capabilities with advanced solution algorithms. Power Factory offers tools to undertake the full range of studies required for grid connection and grid impact analysis of wind parks, photovoltaic plants, and all other power park modules using renewable energies. Power Factory allows the inclusion of complex control dynamics, new generating technologies, blade control, and wind turbulence. So this is a Power Factory 17 base package, and these are the various analyses that can be performed. So these are load flow analysis, short circuit analysis, network model manager, network diagram and graphic features, power equipment models, converter interfaces, load flow sensitivities, overhead line and cable parameter calculations, result and reporting, asynchronous machine parameter identification. It also comes with some advanced functions. So these are some advanced functions that, and these are the various technologies that can be easily done in Power Factory. So these are production functions, contingency analysis, cable analysis, transmission network tools, distribution network tools, power quality and harmonic analysis, arc flash analysis, reliability analysis functions, optimal power flow, stability analysis functions, electromagnetic transients, small signal stability, state estimations, outage planning, multi-static functions, scripting and automations, and a lot more. So before going to the load flow analysis, I'm just switching over to the software and will show you the layout and overall basic functionality of the software. So this is the PowerFactory 2017 Service Pack 2 icon. It takes some time to load. Okay, so the first it's asks about that it's recommended to highly create daily backups of the workspace. So either click OK or close it. After that, the PowerFactory comes with preloaded lots of examples. So we will discuss these examples later. So for now, I'm closing this. So for designing any network, first thing is you have to just create a new project. So this is on clicking on the file menu, there is option new, and after that go to project and just write any name here. Write load flow. Click OK. Here you can write the owner name, either a college or anything, and click OK. So this is the overall layout of the software. It has various toolbars and all have different functionality. So starting from here, this is menu bar. It consists of these various like file, edit, view, insert, data, calculations, output, tools, windows, all these things. After that, it comes the main icon bar. It consists of various icons for performing the analysis in a quick manner. Like if you just want to calculate the load flow, there is this icon. If you just want to have the short circuit, and we can click on this. Create the short circuit value, execute this script, documentation on script, these all things. So all these things are in this main menu bar, and this is one more toolbox. When you will click here, it will show all the various analysis that can be performed by PowerFactories. Like I already shown you in my PowerPoint presentation, like contingency, quasi-dynamic simulations, RMS, modal, harmonic or quality, reliability analysis, optimal power restoration. All these things are here, and these things in more elaborate manner is given here. Like when you will click on the calculation, it will open with more options. Like load flow, we will get the load flow and load flow sensitivities. Same in the contingency analysis, various other options, short circuit, and for that quasi-dynamic simulations, RMS unity simulation, parameter identification, modal analysis, harmonic power quality, reliability assessment, various other different analysis are given here. So this is main menu bar, this is main icon bar. After that, this icon whole, it is called as the main graphics window. It consists of all those functions that is related to the graphics, that either zooming our project or zoom in or zoom out, or if you want to just see the heat map of your network, that what are the different voltage levels of the different part, or if you just want to just move your network from this side to this side, left or right. So all these things related to the graphics designing, all these things are given in this window, this bar. After that, this is project overview window. It will show all the project that are currently active or deactivated. So right now on the default it is showing that grid 1 is active. Either I haven't drawn any network, but it is showing the grid 1 is active. So all those projects those will be active will be shown here. And after that, this is our navigation pane window. When we design any network, and if you just want to see in this small pane, it shows the whole network in this small window. So this is our navigation pane window. This is our the library, the various equipments that we will be using for designing the electrical power systems. Like we have the different types of bus bars, like bus bar, short bus bar, internal nodes, rectangular bus bar, circular bus bar, polygonal, and after that single bus bar systems. We have after that with a tiebreaker, double bus bar system with tiebreaker, and one 1 by 2 bus bar. So these all constitute the various types of bus bar. After that, this all consists of the various types of sites like circular sites, rectangular sites, substations, or rectangular substation, and the secondary substation. After that, these consist of circuit breakers, disconnector, load break disconnector, load switches, fuse. After that, various of like grounding switch, surge arrestor, NEC, NER. After that, this comes a generation unit like external grid, synchronous machines, asynchronous machines, doubly fed induction machines, and this for renewables like static generator, wind generator, battery storage, fuel cell, PV system, various voltage sources like AC voltage source, AC voltage source 2 terminals, AC current source, and the various loads in this like general load, medium voltage load, low voltage load, connection request, with that various filters like RLC, RL, shunt filter C, these all things. After that, the various the lines, transmission line. This is transmission line, series reactor, and after that capacitor. Various types of transformers: two winding transformer, auto transformer, step voltage regulator, three winding, four winding. So all various DC machines are also there. Battery, DC voltage source. Some power systems equipment are also present here like rectifier, inverter, DC connection, 2T DC connection, socket starter. So this is our library to design the electrical network. And after this, here it comes the output window, which shows the error, warning, informations, event, and various things. You can just filter out whatever you want. So like in the filter, I've selected errors, warning, information, events. So you can just choose according to your need. After that, when you will just draw, will ask for output for completing the whole summary of the network. It will be shown in this output window. So it consists of all these toolbars like main menu bar, main icon bar, and this is after our library. This is project overview window. All these things. If you just want to increase the working layout, working window, this is our working window where we will design our network. Just come to here and decrease some size. It will increase and also decrease the size of the output window. It will increase the size. And after that also, if you want to just increase, there is one option of this drawing format, that what kind of the shape your drawing window must be. That there are the various options like here, like A4, A0, A1, A5, B4, A15. This is the oversized. So you can click and change if you want to just draw the big network like consists of large number of buses. If you just want to see in this your network in just one whole page, not like uh, some grids are in this page. After that, you have to just move and see the other. So if you want to just see in the whole grid, you can resize your working window. Okay, and after that, there are the various like on clicking on the file, there is options of import and export. It means if you just want to import or export our data into others, like if you want to just ask any other data to run in PowerFactory, there are the various options available, like the same .pfd file that on which the PowerFactory works. If you want to just import the any other PFD file, there are lots of PFD files available on PowerFactory on internet. So if you just want to analyze all those PFD file, you can analyze. There is on the FAQ session of DIgSILENT. There are the around 291 queries, and in most of the queries a PFD file has been attached. So if you want to just analyze and the example, you can just download those PFD files and import in this PowerFactory software and just see the working and just make you clear regarding the various technologies of that. There are various other system, technologies you can also import. There's also a option of exporting. These are the option of export. On the edit, we have the option of project data, single line graphic, output window. In view, there is option one. This is freeze mode. When you will click freeze mode, our library will get deactivated. After that, you can't edit anything. Right now, I'm clicking on the working window. See, there is no dots as the grid is now. You cannot edit anything. So I'm just enabling the freeze mode. Of that, there is zoom, drawing formats, heat map, all those things. In insert, if you want to just draw the graph, we'll be using later, like virtual instrument panel or all these things. In data, these are the two most important things, like open data manager, network manager. Like we did load flow on any power system network, and we got our calculation that what are the voltage levels, what are the current levels, all those things. So if I just import all those things to Excel format, so these data manager and network model manager works. And after that, these are various things. In calculation, I have already shown the various other analysis and output. There are other analysis and all these things. So this was the quick overview and the showcasing of the software. After that, now I will be going for my presentation and will start my load flow. Okay. Load flow analysis. A load flow calculation will determine the active and reactive power flows for all branches, voltage magnitudes, and phase for all nodes. While analyzing the behavior of existing power system or future system, calculation is required to analyze the impact of commissioning a transmission line or a power plant. For such, two aspects are taken into account. These are present operation and future operation. This is how power should be analyzed. From one side, we require relevant information to obtain the behavior of power system under different configuration that can occur. On the other side, we require the behavior of the system reflecting reinforcement that have not been yet built. The base package of the load flow analysis consists of. So for this, resolving these issues, PowerFactory load flow analysis functions allow the accurate representation of any combination of 1, 2, and 3 phase AC or DC systems. PowerFactory load flow tool accurately represent the unbalanced loads, generation grids with variable neutral potentials, HVDC systems, DC loads, adjustable speed drive, SVS, and all FACTS devices, etc. for all AC and DC voltage levels. Now, load flow analysis environment. DIgSILENT PowerFactory offers the selection of calculation methods, including a full AC neutral interruption technique, balanced and unbalanced, and a linear DC method. The DC load flow, solving for active power flows and voltage angle, is extremely fast and robust with no iterations required. Any combination of 1, 2, and 3 phase AC or DC system can be represented and solved simultaneously, from high voltage transmission systems down to residential and industrial loads at low voltage levels. Neutral conductors can be modeled as explicitly, and the load flow tools accurately represent the unbalanced loads, generation grids, and a variable neutral potentials, HVDC system, DC loads, adjustable speed rise, flex device for all AC and DC voltage levels. Now, the more load balances features, consideration of active power limits, detailed model for generator, MVR capability curves, various active power control modes such as dispatched according to the secondary or primary control or inertial response, support device characteristics such as voltage dependent load and asynchronous machine with saturation and slip dependency, device controllers for shunt, doubly fed asynchronous machines, and other power electronic equipment such as self-commuted converters, thyristor, diode, converters of FET devices. And current representation of transformer vector groups and phase displacement. Shunt can be modeled to consist of a combining of series or a parallel collector capacitors, resistors, and reactors. Feeder load scaling to control power at feeder entry point, including nested and parallel feeders. All operational data, generation and demand patterns, switch position, etc. can be saved. Load flow results. Implicit calculation of large number of individual result variables and summary figures. Display of any variable with single line graphic, station diagram, and tabular flexible data page. Various coloring modes for a single line graphic to visualize quantities such as calculated loading and voltage levels. Detailed analysis reporting, which can list overload system elements, unacceptable bus voltage, system islands, out of service components, voltage levels, area summaries, and more. Detailed textual output with predefined or user-defined filters and levels. Result export to other software applications such as MS Excel. So from here, I will be going to my software and will design a network and will run the load flow on that. So here we again with our software. Okay. So for designing any network, this is our library. It consists of various bus bars. I already told. So the first thing which we have to do is just select the bus bar. So just one left click on the bus bar. As we see, just with the cursor, the one line has been attached. It means right now the bus bar is active. Means it has been selected. Once you click on this drawing window, it will come here like 1 bus bar, 2 bus bar, and 3 bus bar. First, I will be designing very simple network just to give you that how the network have to be designed. So this is the option for zooming. Like there are the various options. Like page means it will come to the reset option. After that, 50% and 75% to make it more clear. So I'm just zooming to 75%. After that, let us introduce a grid on terminal. So on introducing grid, see the grid has been with the cursor. So just click anywhere. I've clicked once and just drag to this terminal. And for deactivating the grid, just have to right click of the mouse, the grid, any option that you have just chosen will get deactivated. After that, introduce a transformer between this and this. So for this, the same thing, just click on this bus bar and drag till here. And for deactivating, you just right click of your mouse and introduce a simple line between this and one general load. See, I can't see my whole network in just single page. For this, you have option of also resizing the equipment. Like means right now the grid is long. So if you just want to decrease the size, because it will not affect the power system network, because already we are here just simulating. So for this, just select by clicking on left click and just drag, move the mouse downward. It will, the size will decrease. Let me have some more size. Okay. The same with the two winding transformer. Just decrease some. Okay. And same with this. Some more. So see, on this 75% zooming level, we can see our whole network. Okay. So I have drawn very simple network consisting of 3 bus, a transmission network, a one grid, after that a transmission line, and a one transformer with one general load. So our diagram is now complete. After this, I will design the more diagram. I will analyze the load flow analysis on those. So right now, as the diagram has been already drawn, so the next thing is you have to just click on the various elements. Like I'm just clicking on this bus bar. 2 clicks on this, just edit the name as bus 1, and these are various options. Like system type is, you can just change system type AC. After that, phase technologies, various different phase technologies are present here. Yes, you can choose that what is the usage of bus bar, that either it is being used as a junction node or internal node. It's asking of the line to line voltage, where you can edit the line to line voltage. After that, and it will also convert to line to ground value. So these are the options. The load flow also, you can write the target voltage. You can just control the voltage. For that, you have target voltage, data Vmax in percentage, Vmin, priority, steady state, voltage limits, these all things. So right now I'm just entering the very basic data. Means it is the default value, that line to line voltage is this much, 110 kilovolts. So just 110 kilovolt. Okay. Now a transformer is there. So double click on this. In transformer, we got the various options. Like you can get the option of number of parallel transformers, which you just want to have the transformer out of services. Check it here. Thermal rating factor, you can edit. You can, if you want to just increasing it as a auto transformer, just take it here. After that, neutral conductor, you can add AC, separated these things. Internal grounding impedance, high voltage or low voltage, star connector or not. These various things are here. And in the load flow, we have tap changer, tap controller, and various advanced features like thermal loading limit, maximum loading, all these things. These are the various options, norms for the calculation of the short circuit analysis, like VDE, IEC. I will be showing you in my presentation later. VDE, IEC complete is also known as short circuit, ANSI and IEC. So all these things will be used when we are using or performing the short circuit analysis, and various other things available for in like in RMS simulation, RMS root mean square speed, EMT electromagnetic transients, harmonic power quality, protection, optimal power flow, state estimations, reliability. So these are some advanced features which you can use, but for now I'm just going very basic by entering the very basic data. Like here I don't edit anything. Click on the type. There are the 3 options available, like global type, project type, and new project type. So on clicking on the global type, it shows the various options that are used globally, the transformers. They are globally used as of two types, like 50 hertz and 60 hertz. So you can select. So the default is 50, so leave it as it is. And after that, we just, when you have to create a new project, we will go into new project type, and this is our two winding transformer. Just change the name as XMA 1. Technology is three-phase transformer, single-phase transformer, single airbag certain. Leave. Rated power is 1 MVA. Right, is that 25 MVA. Nominal frequency is okay. High voltage side will be 110 kilovolts, because the transformer that I'm considering is step down transformer, and it is connected on the primary side with the grid having voltage of 110 kilovolts. I am just stepping down to a level of 11 kilovolts. Okay, and after that I'm just leaving with all this. Like, we can also add positive sequence impedance. We just want to have the grounding impedance, all these things, so will add zero sequence impedance, short circuit voltage, HSC voltage, all these things. You can also have, if you want to change the vector groups for high voltage sides, the various vector groups are given here. Same for the low voltage side. If we just want to have introduce a phase shift, we can change there. Okay, the load flow option, we can add for the magnetizing impedance, no load current, that is in percentage, no load losses in kilowatts, and after that zero sequence magnetizing impedance, R by X ratios, distribution of leakage reactance in PU, execution high voltage side for low voltage side, same with the zero sequence leakage impedance, all things are available. Same with the short circuit that I've shown with the bus, for the bus, same with this. If you just want to have the short circuit calculation with this norm, that is VDIgSILENT technology, so we will be adding all those things here. If we just want to use this, and of that ANSI short circuit IEC 61663, so various options are available here. So for now, I'm just rated the rated power and nominal frequency, HV side, and all those things. Click OK. So after that, just change the name to bus 2. All those things are same system type, but here the line to line will be 11, because I stepped down to 11 kilovolts. So nothing to change in the load flow data. Just add all. In type, there is nothing. In the nominal voltage, just rated 11. Okay. After that comes to line. Here it asks about the length of the line, right? I'm just entering the any data that comes in mind. So you can add any practical data. Means if you are designing a network and you have those practical data for like 9 buses or 14 bus system, 39 bus system, because their data are pretty fixed, and so you can use those values. And after that, for line, we can also add the rating factor and the laying of the line, that whether it is ground or in air. And after that, the line model, what is it? It is lumped or distributed parameter. And after that, the number of parallel lines. So the type, again, there is global type. So right, see, there are the various global types for this is available, like 10 kilovolts, 15 kilovolts, 1 kilovolt. So when you will click here, double click, it will ask for that which material is made, of which material it is made of. So it is, there are two options are there, aluminum and copper. So click, I'm just clicking on aluminum. After that it will ask about the materials used, all those things. Click on PVC. So it will, so all those options that are used globally for transmission line, like NASCY 3 into 150, I don't know all these things. You just click and click OK. Once you click OK, all the data that are fixed according to this uh, material, all those things will get imported. Like here, I haven't entered any value, but here you can see the rated voltage is in, already been added 10 kilovolts, rated current, nominal frequency, system type, AC resistance, all those things are itself added. But the thing is, we can't edit all those things. These are fixed. Just if you just want to use those things, like if there is an example and it is saying that the cable is of NASCY this type, so just click and import all the data. So here we can't, here you see that we can only read only, and just we can implement and we can use this value. We can't just edit, and like I can't edit AC resistance 7. We can't edit anything, just we have to just use all these values. So for now, click on OK. And if you just want to have our data, we will go with new project type, in which there are the various options available, like line type, tower geometry, cable definition. So click on the line type. The same options comes here, but here see there is option of editing also, and all those values are here 0. Okay, the line type, the line is only 1. So click on line 1. Rated voltage will be 11 kilovolts because it is corrected on grid, on that grid. Leave current as it is. Cable I am just selecting overhead. System type AC, leave it. Phase is 3. Okay, you can also have the number of neutrals of that. For the AC resistance, write any random value. 5, 4, 3, 6, 5, 4, 3. Okay, and number of neutrals. Okay. What is in the load flow? Let me check. In the load flow, these are various options available, like parameters per length, 1-2 sequence, maximal operation temperature, AC resistance, conductor material, that which conductor. These are the various materials. After that, parameters per length, that is 1-2 sequence for susceptance, Innes factor, 0 sequence, all those things. And again, the same various technologies for analyzing the short circuits, VD, IC complete, all those things. So I have already entered the data for this line 1. Click on OK. And at last, this is terminal bus 3. This is bus 3. Here, as the no transformer is there between the bus 2 and 3, there is a transmission line. It will have the same line to line voltage. Line to ground will convert after clicking OK. And after that, the last is general load. In general load, click on type, click on new project type. Two options available: general, complex. Click on general. Load 1. Edit. Okay. Load 1. And after that, click OK and go to the load flow. In the load flow, you have to just edit the active and reactive power. Like in the input mode, there is option of, like we have default. Right now it is default, but see there are various options. Like if you have the data of active and reactive power, you can choose this. Here data of active power and the phase difference cos phi, We have the data for current, for SPI, after that reactive power. This is for MVA, total MVA, and after that reactive power. So you can change according to that. But right now as it default, so write anything, any data, 0.2. So I have edited all the values, like for starting from the bus 1, then transformer, then bus 2, then line, then bus 3, and this load. So as I have edited the data for all the equipments, after that just go to the calculation, click on load flow. See, there are options of AC load flow, balance positive, and AC load flow unbalanced. So much more. In the general load, in the load flow, there is option of input method default, but there is one more option, balance and unbalanced. Like I have entered the data for balance, but if you will choose unbalanced, you have to just fill the data for each phase for active and reactive power, like for phase 1, phase 2, phase 3. You have to just edit all the values for all phases. So leave for balanced. Okay. Load flow, and since the calculation methods are available with like AC load flow, balance, positive sequence, AC load flow, unbalanced. We will be when we have selected that unbalanced method, then we will be using this calculation method for load flow calculation. But for now, as we have taken for balanced and positive sequence, so we will go with this. Execute. Okay. See, the load flow has been executed and it is showing the different color for the different buses. This is because of the different voltage levels of the different buses. Okay. Okay. So what's next? So we can see, we can saw the heat map of this diagram. Execute. So this is the heat map of this diagram. Okay. So what does heat map represents? So these are low voltage range. Like if it is 1 pu, it will show green. It is 0.9 per unit, or it is 0.9 pu. It shows all those things. Okay. And various other options, like if you just want to see the animated load flow, means like the current is flowing from one bus to another bus. As we see, this network is pretty simple, consisting of 3 buses, and there is no other branches for the buses here. So here the animated load flow might not look that much effective, but with the bus systems like 14 and 39 bus, where there are lots of buses, lots of equipments connected to each other. So there will be, right now I'm showing the activated load flow. Like here, right now the direction arrows are invisible, so I'm just making it visible. Just put it here to direction arrows. Okay. After that, go to option, this graphics option. Click there. Use option of advanced. Click on animated load flow. Click OK. After that, calculation, again go to load flow and execute. See, it is showing that this is the way of current, direction of current that is flowing. Okay. For making this animated load flow stop, press the escape button from your keyboard. Okay. So after that, what we can do? One more thing. If we just, this is vertical diagram. If we just want to just make it horizontal, please select the whole diagram. And after that, click on this. There's option of rotate clockwise, counterclockwise 180 degree. Click on counterclockwise. See, we have seen the networks in this design, in this layout also. So just showing that we can also draw, or we can also rotate any diagram like this, because we have seen various networks in books in this horizontal manner. Okay, I'm zooming it to make it more clear. After that, as this bus 1 is showing the kilovolt value, PU value, current for n degree. Okay, if you just want to see the more values for that, there is one option available, that is for format for nodes. In format of nodes, we have options of like either we can left it empty, or we can see the line to ground voltage and angle, and line to line voltage and angle. The default is line to line voltage, but we can also see the line to ground voltage and angle. If we are not satisfied with this, we can go with edit format for nodes. Click there. There are three variables here, like line to line voltage and magnitude, voltage and angle. If you just want to more, so insert, click on append row. One row has been added. Click on the variable. When you will click here, another variable selections box will open. In the variable selection box, there is various options available for the calculation. Means variable set is here, current, voltage and power. So there are lot more variable sets. There is also element parameter and the reference parameter. There is nothing reference parameter. Click on current, voltage and power. If we need to see, or we just want to get the voltage in PU, real part or imaginary part, magnitude of positive voltage, real part. So just click here, like in imaginary part, and after that click on positive sequence voltage and click OK. See there now, before appending the row, it was just 3 variables, but for now it is having the 6 variables, and click OK. See now the every bus is showing the 6 variables. So just if applicable for that component, that data is being calculated for that while performing the load analysis, that can be seen by just clicking on this and appending. So okay, and what next is there is option you can okay output calculation. There is option of output calculation analysis. It has the options like bus bar terminals. When you just get the data for the bus bars, total summary or grid summary of complete system report. Just clicking on the complete system report, it will ask for which kind of report you want. So there is if you just want to have the report for substations, voltage profiles, grid change, click on OK and execute. So all those data managers, all those things will be shown in output window. See, just maximizing the output window. So overall system report has been created. It is showing first that in how many iterations the load flow has been executed. After that, from here it is showing the overall system report. See the power factor, this is dated, all those things. System grade is study case. Of that, it is showing the values for bus 1, bus 2 and bus 3 for rated voltage, and of that bus voltage PU, kilovolts, angles, of that active and reactive power, that active power in megawatt, reactive power MVAR, power factor, current, loading, and the various other additional data. For the bus 1, again in graphical representation, it is showing the voltage of the grid, voltage level of the various, like for generation. These things are not, as a diagram is pretty simple, consists of not even a single generator or motor or anything like such. So it is, all those things are 0. But for the practical systems, for the big systems, distribution system, it will show the whole system report. So this is the use of the output system output window. It will show the error, warning, informations, event, and these things. Okay. You can also clear it with the option of clear error and click on OK. So this was this. After that, if we just want to import our data to Excel or all these things, there is option of Open Network Model Manager. In this, we have our network consists of how much components? It consists of substation, bus bar, terminals, cubicle switch. It consists of bus bar. How many bus bar? It consists of 3 bus bars. Okay. Now after that, it consists of one line, one general load, and 2 winding transformer. Only these components our network is made of. So for the bus bar, as I've selected the bus bar, it is showing that we have 3 buses and 3 buses. And clicking on the flexible data, it will show you the various all those things like nominal line to line, kilovolts, PU, angle. All those things are given here. Okay. So what we are going to do is just click on the control button and just select all the 3 buses. And after that, right click on it. The option is spreadsheet format, and after that go to copy with column headers. Copy it and go to MS Excel. Blank workbook and just simple paste. You see all the data that we gathered for any kind. Means I have like chosen for the bus. The same we could do with the 2 winding transformer. Right now we have just one transformer, but if there will be having lots of transformer, we can copy, but we can also copy this. See, it is showing the various rated copper losses, all those things, all those data are here, the basic data. So this is the option for just copying all the data to the spreadsheet format. Okay. I told about the navigation pane window. See, our navigation pane window is showing this whole network in this small pane. From here we can design. From here we can see that it consists of 3 buses and transmission line and all those things. So navigation pane window is not of much need, so I'm just closing it. Okay. So for now, I'm just designing another network and just go to file, new and project and click on OK. So from here I will be designing the network consisting of 5 bus, 1 grid, and 2 transformers, 2 step down transformers, and 3 loads. Okay. So for this, let's introduce the 5 buses first. 5 buses. Just introduce some space. I'm just okay. Minimize the output window to have more size. Same for the grid overview window. Okay. Reduce some little space between all the 5 buses. Okay. So the next thing is we have to just rotate our bus, because this network I'm drawing horizontally. Click on counterclockwise. Click on clockwise. Okay, clockwise. Yes. Okay, just adjust because we will be introducing the rest. And for moving the equipment, you have to first select, and after that click on it. When this cursor will appear, just drag wherever you want. Okay. Okay, the next thing is that I have introduced a grid here. You can also add here the synchronous machines, asynchronous machine, all those things. But the example that I have consists of grid. Okay, after that the transmission line. Okay, and after that transformer. With same again line. And again once to another transformer. After that I will connect the load. So choose load. So our network is now ready. I'm zooming more as this is our network. Okay. One thing I haven't told you that this grid will take the default value that it is as connected with this um, bus, so it will have the same. And so for grid we haven't the options available for editing the values. We can only for the grid we can only edit the active and reactive powers, all those things. So starting with grid, it and going to the load flow, we have the bus type is PV. Okay, and set point limit, and input mode is default. And after that active power, write it as 2 megawatts. Voltage set point is okay, leave it as default, that is 1 pu, and leave reactive power as 0, and nothing to edit here. Low PV bus, voltage set point is 1 pu and active power is this much. Click on OK. Starting from this bus, first thing is just change the name bus 1, and this is at 33 kilovolts. Okay, 33 kilovolts, and in the load flow there's nothing to do. Okay, okay. Now that the second, I'm just entering all the buses data. So this will also be at 33, because there is no transformer between them. After that I haven't left the name bus 2. Okay, after that there is one transformer, This sample I'm considering is a step down, so I'm just waiting the value for this as 11 kilovolts. The terminal was 3. After that, again the same. First thing is to read the name bus 4. Again, there's no transformer between them, so it will have the same 11. After that, the bus 5. Click on that. Let me zoom to 50% level to have the whole diagram in visible. Okay, I have edited the values for all the buses. Now I'll be going with line. So starting from this one and having the name as line 1. So the data that I have having is the length of the line is 10.12 kilometers. The rating factor is leave it as it is, and the laying is ground, and there is nothing to do here. Lump parameter, okay. Go to the new project type and line type, line 1. Rated voltage that I have, that not the it will have the same as bus 33. The rated current that I have is 42.41. After that, it is of type cable. The AC resistance is 3454. The reactance is 9234. AC resistance is this much, and okay, phase 3. Okay, click on OK. Length of line is 10.12. And after that, it's the same. This value, all value will be same for this also. It is connect as if they are connected between those two buses. 10.12, new project type, line type. Rated voltage is 33. Current is 42.41. Resistance is 0.3484. The reactance is 9234. Cable type, okay. After that, this line 3. The length of the line for this is that the data I have is 2.67. Okay, and after that, going to the type, line type, the data, the rated voltage will be 11. Resistance type is AC resistance will be, and one more thing, rated current 12.34 kilo amps. And after that, AC resistance that I have is 0.1204, and it is 2304. 1204 and 2304. Click on OK. So I have edited all the values for line. Now I will going with transformer. Making more zoom. Transformer. For the transformer, the new the rated power is 150 MVA, and high voltage side will be how much? It will be 33. Low voltage side will be 11. Okay. AC voltage that I have is 10%, and the copper loss is 10.5 kilowatts. Okay. Okay, 150, 33. Click on OK. Update the second transformer. New project type. For this I have rated as 150, and high voltage side will be 11, and the low voltage side be 0.4 400 volts, and the short circuit that I have is of 6%, copper losses 7.5. Okay, I haven't rated for this will be 0.4 because this transformer is stepping down from a level of 11 kilovolts to 400 volt. Okay, now after this I will be going with load. Starting from this, change the name. To okay, now starting from this load, load flow. Load flow data that I have is P cos phi. So active power is 0.78, power factor is 9696, and the voltage set point is 0.9534. Click on OK. Come to this. Again the P cos phi, and for this we have 0.65, and power factor is 0.95, and after that the voltage set point is 0.9565 pu. The last, that is load 2, load 3, zero point 0.45, 0.92, 9123. Okay, so I rated every values. Now going with calculation, load flow. Okay, the load flow has been executed. Okay, the load flow has been executed. All the same option will be for this also. The gate map, and after that the diagram coloring scheme, all those things. that direction arrows. Okay. The animated load flow. The next most important thing that I will be doing is inserting a virtual instrument panel. Virtual instrument panel, that is for the drawing the graph. Means we have the various options available like bar diagram, subplot, digital plot, harmony distance, XY plot, time over current, eigenvalues, mode phasor plot, mode plot, all those things, voltage set point. So I'm just going with subplot or click OK. The virtual instrument panel has been introduced, but the next thing which we have to do is to define that for which we just want to see the graph. So first thing is just define to this value, that is for xmer. So right click on it, there is option of define. After that there is option of result for RMS EMT simulation. Click on result. After that this is xmer, this is selected xmer1. Okay, when you will click here, the same the window for variable selection will open, and the reference will go to the calculation parameter. I just wanted the loading graph of this transformer. Just check the loading, click OK and close it. And for the second transformer, the same, define result for an SMT simulation. Select for this calculation parameter, again the loading for second transformer also. Close this. And what next? We want the bus voltage for this. Okay, define bus 3. What we want is voltage magnitude in PU. Okay, already been selected. U1 voltage magnitude. Click on this and close it. And the next thing which you can choose is this line for MSMD simulations. Calculation parameter and click on loading. So we'll just introducing all these components and selected the variables. So the next thing which we have to do is just mentioning those all equipments from here. Okay, so as I have double left click on it, after that element, this box will appear. So you have to just introduce all those components one by one in this box. So what we have to go to all calculation. Okay, and that what are the elements? The elements are, first one is line, click on OK. Insert in the very next row, again the same, all calculation, click OK. Element is bus. Okay, again insert row, all calculations, element is xma1. And the element is xma2. Okay, I've introduced all the elements to the graph. Or that this next thing I have to do is defining the variables that I have selected for them. So xmer2 I have selected loading, click on OK. Xmer loading, bus 3 is magnitude, and for line again the loading. Various colors are here, brown, blue, green, all those things you can also change. So I'm just changing the brown because I don't like brown, so just change to okay, black. Black. Change to this. Okay, there are various style can change the width, all those things. Okay, and click on OK. So here see the four, all those we have just defined here. Seen the XMR 2 loading, 1 loading, bus 3 we have voltage magnitude in P1, line 3 it is also loading. After that go to this menu, calculation for the initial condition. We just want RMS values for electromagnetic transients. Click on execute, and after that go to this edit 5 4 any second and execute it. So right now it's just showing the two, that is for line loading, and which one, the green one, that is bus voltage magnitude. So we have to just adjust the graph for that. Okay, see the graph has been drawn for all the four components. This is line, the loading for this is the lowest in this line. This is for XMR 1, and the two, let me zoom. See, there are two parallel lines. Okay, and the bus voltage 3 here, and after that this one XMR 2 loading percentage. So this is the graph. If you just want to increase in, see in bars, just click on this, it will show the bar value. Okay, this one. So this was all about my load flow. From here I will be going again to my presentation and start the short circuit. We'll start short circuit. Okay, short circuit analysis. Introduction. Power system as well as industrial system are designed so that the loads are supplied safely and reliably. One of the major aspects taken into account in the design and operation of electrical system is the proper handling of short circuits. These are the typical applications of exact methods such as superposition method, which is based on a specific network operating point. The short circuit calculation in PowerFactory is able to simulate single faults as well as multiple faults of almost unlimited complexity. Although systems are designed to stay as free from short circuits as possible, they can still occur. The short circuit conditions generally cause large uncontrollable current flows, which, if not properly directed and handled, can result in equipment damage. The interruptions of large areas instead of only faulted sections, as well as placing personnel at risk. A well-designed system should therefore isolate the short circuit safely with minimal equipment damage and system interruptions. Base package of short circuit analysis. Short circuit analysis, power system as well as industrial. Is my voice audible? Please message, reply on chat boxes. Short circuit analysis introduction. Okay. Okay. Short system analysis introduction. No, I was at, oh, no, I was at that second slide. The base package of short circuit analysis. So PowerFactory provides the following calculation methods for short circuit calculations, like VDE 0102 German VDE standard, IEC 60909 International IC standard, ANSI, the American ANSI IEEE C37 standard, complete superposition method with which considered the pre-fault load results. And after that, IEC 61363 electrical installation of ships and mobile and fixed offshore units, and various others like IEC 660, ANSI at 99946, etc. Short circuit calculations performed at planning stage commonly use calculation methods that require less detailed network modeling, such as methods which do not require load informations and which will apply at extreme case estimations. PowerFactory application is the precise evaluation of the fault current in a specific situation, such as to find out whether the malfunction of the production device was due to relay failure or due to consequence of improper setting. Features and options. So DIgSILENT PowerFactory features fault calculation functionality based on generation, international standard, as well as the most accurate DIgSILENT general fault analysis method. Beside load flow calculation, short circuit is one of the most frequently performed calculation when dealing with electrical networks. It is used both in system planning and system operations. Typical examples of short circuit analysis in system planning include ensuring the defined short circuit capacity of equipment is not exceeded with system expansion and system strengthening, coordination of protective equipment, fuses, overcurrent distance relays, dimensioning of earth grounding system, verification of sufficient fault levels, capacities at load point, uneven load such as furnace, thyristor, drive and variable speed drives, or dispersed generation. Now, the complete method for this. The complete method superposition is in terms of system modeling and accurate calculation method. The fault currents of the short circuit are determined by overlaying the healthy load flow conditions before short circuit inception with a condition which all voltage supplies are get to zero and the negative operating voltage is connected at the fault location. The initial point is the operating condition of the system before short circuit inception. This condition represents the exciting condition of generator, tap position of regulator transformer, and breaking switch status, reflecting the operational variation. Now the reporting option and for the results. Detailed analysis reporting, which can list overloaded system elements, unacceptable buses, voltage, system island, out of service components, voltage levels, area summaries, and more. Detailed textual output with predefined or user-defined filters and levels. DPL interactivity with all results. Result export to other software applications such as MS Excel. Implicit calculation of large number of individual result, variable and summary figures. Display of any variable with a single line graphic, station diagram, and a tabular flexible data page. And so this was all about the short circuit, and from here I will be going to short circuit, performing short circuit analysis. So I've already drawn this network, so I will be just doing the short circuit on this network only. There is no need to design any other network. I'm just showing the functionality of the software, that what are the various options available with this, the short circuit analysis. So this is our network. Just have it more to 50%. Okay. After that, go to short circuit analysis and click on short. This short circuit analysis, here are the various options. Like it is first asking about which method you just want to choose. So on clicking it, we got all those methods that I was telling in my presentation. The VD0102, IEC 60909, ANSI complete, IEC 61363, IEC 61660, ANSI IEEE 946DC, all those things. They're also asking about in which year it was published. In the 17th version, the 2016 publication technology has been added. This was not before. So this was new in this. It was whether it was published in which year, 16/1/90. It is also an option of fault type, that which kind of fault type you just want to choose. It have three-phase short circuit, two-phase short circuits, single phase to ground, two phase to ground, one phase to neutral, all those things. Three-phase short circuit unbalanced, three-phase neutral to ground, all those things. What you want to calculate? So in calculate we have maximum short circuit currents, minimum short circuit currents, maximum voltage tolerance for this thing. For the short circuit duration means break time, use break time, the global, local, all those things. Fault clearing time, you can edit all those things. After that, fault impedance, resistance, and reactance. Fault location, you can also check that what are the fault location, bus bar at junction nodes, all those things. In the advanced option, we have the voltage factor for all those things. Of that, grid identification, automatic mesh. Various advanced things are here. Like if we are having the synchronous motors, asynchronous motor, we will be ticking all those things like always consider neglection. All those things are available here. Okay, so just going by the default value and click on execute. So this is our load flow and our short circuit analysis. Okay. So as we see, the short circuit runs accurately and it is showing the various MVAs, amperes value and all those things for every single bus. So accordingly, we can design that which bus is out of control. So the control manager could work upon them and will decide that what are the process and how are going to control our network. Okay, so there there is not much. There are various options available in the short circuit analysis, so you can choose according to your need that what you want to just do with this. So this was my short circuit analysis, and after that I'm just showing the very different examples that comes with PowerFactory. So because these were the networks having that consist of only 5 buses or 3 buses. So but the PowerFactory comes with lots of preloaded examples. So just there's a click on example. See, there are 3 options available, like application examples from the literature and from the standards. In the application example, you will get the various like low voltage distribution network, medium voltage transmission systems, distance protection, state estimations, industrial network. These are the tabs. When you will click on this, there is a video tutorials available. Like for the base model, like in the base model, the something written is that is introduction to the base model used in low voltage distribution network. Example study case. Same with low voltage load flow calculation, feeder load scaling, positive dynamic simulations, cable reinforcement. Same with when you will click on medium voltage distribution network, there are various options available. Same with transmission system, distance protection, state estimations, industrial network, hydropower plant, wind farm, offshore wind farms, relay systems. Okay, and in the literature, there are the they have been picked from either from any book or from the these things like see in the 9 bus system is introduced in book power control system and stability. So it has we have 9 bus system, 14 bus system, 39 bus system, all those things. And after that example from the standard, these are the various norms that I was telling for the short circuit, performing short circuit. So start with the I have this drawn for the 5 bus, but so and so I'm just importing this. Now, let me continue. Okay, first just see the documentation for this 9 bus system. See, 9 bus is silent. It will so it shows abstract the various general descriptions, the model parameters, various formulas, and the single line diagram for the 9 bus system. And what are the various things that we could draw, like for the load. These are the results of the load flow. After that, comparison of rotor various angles. These are the various diagrams and we could draw. And these are the data from bus 4, 5, 6, 7, 8 lines, various lines transformer. These are the various data. Okay, so for now, just close it and just import this 9 bus system to our so see the 9 bus system has been imported, but right now it's only just network. So what we just want to do is just calculate the load flow for this, execute it. See that the load flow data, the load flow has been executed. But this is our load flow data. Starting from this, from every bus, we have the various data. Okay, these are the graph or the voltage levels of the all of the 9 buses, and these are the powers MVS values for the 3 generators. As in the 9 bus system, we have 3 generators. So these are the that. See, as I have already told, this is our project overview window, and right now it is we the active project is load flow because I perform the load flow. But there's the various options like 5 cycle classical SG model, 3 cycle classical SG model, 3 cycle amphidyne. These various other options available. So if you just want to just activate any of the option and just because right now as the load flow is in bold, so this is activated. So for activating any other, just right click on it and click on activate. Okay, when you will click on 5 cycle classical SG model, it will show the diagram for the rotor angle. Okay, that was in the documentation that I was showing you before. In the same way, there was option of 3 cycle classical SG model. The same way, just activate this, and here again there will be this graph is drawn. Click on. Okay, so as I've already told, this is our project over window. It will shows the all the projects that are available for this 9 bus system. So in 9 bus system we have load flow 5 cycles. These also. So you can activate any kind of study cases and just analyze. Means in a load flow there was graph of only voltage and power for both all the buses. Okay, but in the classical 5 classical SG model, all those things, we just got the graph of rotor angles. So in the same way, just click on activate this one, and there is a comparison of excitation models. So in the rotor angles, we'll get this voltage. We can also perform the Prony analysis on this, that is frequency analysis. Just um, frequency analysis. See, this is the Prony analysis of this, the graph of the upper one, that is for the generator. This is the Prony analysis for this. Okay, rotor angle. So we can also adjust these graphs from here. All those things. This is the fast Fourier transform. This is fast Fourier transform, that is frequency analysis of this. Okay. In the same manner, you can also import the various other examples also. There's in the 14 bus system, we will be having the same thing. The same options available with those also, with this 14 bus system also. See, this is our 14 bus system. Same, go to load flow, execute it also. But there are also options available, like the load flow. We can also have load flow contingency, short circuit, metal reduction, quasi-dynamic simulations also. Just click on quasi-dynamic simulations. It asks about a load flow balance, passive cans, these all things. What are the time period, complete day, complete month, user defined time range, maintenance events, all those things. Execute it. Okay. Cannot be included collected month starting off. Leave okay, let's start. Let's see what happens after that. Leave. Okay, after that, optimal power restoration. Fault location. You have to just select the fault location. After that, you can also execute the optical power restoration of that. Optimal capacitor placement, production, and cable analysis. So these are the various analysis that we could also do, but I'm just showing you for the short circuit and the load flow. Okay, I'm clicking on the example. This example is that low voltage network is that. Just import this also. This low voltage distribution network consists of thousands of bus bars. That's why it's taking some more time. Okay, so this is the 400 volt diagram. Okay, so see, I'm just going with the load flow and calculates the load flow. Okay, it says last command leads to see an output window. Okay, and we will go to output window and see the error. It shows maximum number of node exceeded. What does it mean? It means that this bus bar consists of around thousands of bus bar, or 20,000 of bus bars, and the power factory version that I have right now having is limited to only 250 bus bar, as power factory comes with two versions, that is power factory education and power factory research, in which the education version is limited to 50 bus bar, and the research version is, there is no limit of the designing, there is no limit of the bus bar. So I have the version in which we can only simulate the network consisting of 250 bus bar. So that's why I can't simulate this, but we can see the various of the voltage levels, the various, like see the heat map of this. See the heat map. The various networks have different. Okay. So again, this is 10 kilovolt system. This is 30 kilovolts system. So these things, these all things will get simulated in the research version because it consists of very large number of bus bars. Okay, like if you just want to just import any project from, like, click on the file, click on import, click on data. After that, I typically I have downloaded some PFD file. Like I have downloaded some of the PFD file for the HVDC and facts analysis. So I have just downloaded this generic statcom model. Just you can download any file from the FAQ section of the DIgSILENT and just simulate. Right now, just generic statcom model and open it. First thing is to execute. After that, activate it and search for general statcom model and click on OK. See, this is our statcom model. This is our network diagram. This is our simulation plot. You can just run, execute. These are simulation plots. This is controller block diagram. This is statcom frame. So there was one query of regarding the fact analysis. So I worked upon this and just searched for the fact analysis models. So I came up with this statcom model. So facts analysis, all those things can also be can be simulated also. So this is our statcom model. So this is option of, this is the way we can import any PFD file available on the internet and just analyze on the PowerFactory version and this thing. After that, what are the various things available? Yes, after that we have the option of, in the help there's options like tutorial, start tutorial, user manual, what's new, release note. In tutorial, when you click on tutorial, on clicking tutorial, you will get the brief introduction. This PDF will have around 100 pages, and here you will get the how to use the software, documentation, help system, program review. Means this PowerFactory has two way of working. You can also work on GUI based, that is graphical user interface, and the other method is for programming, that is for DPL programming, DIgSILENT Power Programming Language, and another one is DSL, DIgSILENT Simulation Language. You can also work by those methods, but those methods needs lots of learning. So right now I'm just showing for the GUI, means just pick and drop and design the network. So you will get the various, like I've just seeing the, for creating the system element, you created selected creating system elements. Here you will get the from the very beginning, that how to just draw the network, how to just create the values, all those things, how to just import the graph, all those things that I was telling here. That means for how to append rows, how to just choose the selection parameters, all those things are here given here. And in data manager, how to just import all those things. So all those things are given in okay, cancel. In user, the most important in this is user manual. This is very big. This has lots amount of pages, have around 1213 pages, and it consists of overall functionality of this DIgSILENT PowerFactory. And the most important section is this, all system analysis functions. All those functions that I was telling before, like for starting for load flow, the short circuit, outage planning, all those things, till to the motor starting, means all those 46 analysis. Lots of pages are given with each analysis. So you can study and just design and just learn more and more. So get more familiar with this PowerFactory. Okay, so this was all about Power Factory working and source analysis. After that, few slides are left for the script or system integration. Okay, power system integration. So the silent programming language offers an interface to the user for the automation of tasks in Power Factory by means of simple programming language and inbuilt editor. The user can define automation commands, scripts to perform iterative and repetitive calculation on target networks and post-process the result. The DPL calculus commands can be used in all areas of power system analysis such as network optimizing, table resizing, project coordination, stability analysis, parametric sweep analysis, and contingency analysis. Now GIS integration. So GIS integration is preferably implemented via DGS interface as object and parameter definitions at the GIS side usually reflect user specific needs. So the data we recorded from the GIS, that is geographical information system, is first transferred to the DGS where some kinds of data like generation and consumption is added, and then the power factor is linked via DGS, causing the DGS data to be simulated easily. And after that, interfacing with this SCADA, the power factory OPC, that is object linking and embedding for a process control interface, is an asynchronous communication and data exchange mechanism used in process integration and is widely applied in SCADA and control system. So after this, we will be having the hands-on session. So from here, I will be taking few minutes break, 15 minutes break. After that, we will again come to hands-on session on the silent power factory. And after that, at the end of the session, we will be having the question answer session. Okay. But if you have any queries for now, you can just write on your chat boxes. I will work upon them and will answer you. Okay. So I will, after the 15 minutes, we will be having this hands-on session. So after 15 minutes, please be here. We will be having the hands-on session. Good afternoon, everyone. Once again, so from here, the I will be designing the network, and I will be going very slow, step-by-step process. So just copy me if you have any queries that you can ask on your chat box. So I'm going from very starting and just closing the software. Okay. So the first thing is just click on the. I've already uploaded a hands-on manual on hands-out section. It already have the step-by-step process, so you can refer from there also if you're having any query. So see, this is my hands-on manual that it's starting from click on the Power Factory's Specs 2 icon. A whole this PDF consists of various steps. So you can also give this PDF to any other faculties if they will be needing for this, and by just going step-by-step process, you can design any network and you can just give the overall functionality of the software. So you can download the hands-on manual from hands-out section, and okay, so first thing is just click on the Power Factory Service Pack 2 icon. So please ask for examples. I've already shown the various examples that are preloaded with the Power Factory. So for now, just close it. The first thing is the first window that comes while after opening the silent Power Factory is this. This is blank. There is no project overwind window. There is no active library. The first thing is what we have to do is click on the file menu, go to new. And after that, there are three options: project, derived, combined project. As we are designing our own project and we are entering the values according to our need, so click on project. So in the basic data, here you can specify the name of the project. So write as whatever you just want. I am writing a hands-on, and after that it's go to OK, and owner I'm writing is DELSoft T. Click OK. So this is our layout of the software that I have already told, and this is the project overview window, various all these things that I have told before the break. So what we have to just do, I'm just designing the same very simple network, because in the hands-on session, you will just learn that how to just edit the values, or to just draw the network, or what are the things that could easily do with Power Factory. The first thing is clicking and choosing and dropping. The first thing is, so what you have to do is just left click on the bus bar once left click on the bus bar. As we see this cursor, there is the bus bar comes with this. That means it is now activated, that bus bar is selected. So as the bus bar is selected, what we have to do is just click 3 times. How many times we click on drawing window, that many of the bus bar will come from the library. Okay, so I've just clicked 3 times on drawing window, so we have 3 bus bars. And after that, to deactivate this bus bar, what we have to do is just right click on it, and it will be deselected. Okay, the next thing is, if you just want to move the network, what we have to do is the same very simple process of selecting. We select like this and drag any one of them, because as all the three buses are selected, just click on any. As when I clicked on any of the bus bar, this cursor will come, and after that just we can move the whole network from according to your need. And the next thing, if this is very small bus bar, so if we just want to add like there is one transformer, there is one grid, and there is one load, all these things, so this is much little space, so the equipments that connected quite close to each other looks kind of messy. So first thing what you could do, select the bus bar and click on this, and the cursor will change. And what the next thing you are going to do is drag to the right side. The phone, the bus bar size will increase. See, same method, drag like this. Just okay, and same for this also. Okay, so I have now 3 bus bars. Okay, what the next thing is, what are the various options of zoom? This is zoom in. So for zoom in, what you have to do is select the zoom in option. When you will select zoom in, the magnifier, the cursor will change to the magnifier. The next thing which we'll be doing is select the network. It will get zoomed. And again, if you just want to zoom this only, this bus bar only, okay, once more, it will zoom. So this is used because when we don't want to just zoom the whole network, we just want to see the data or anything for any single component, so we can just have this icon. And after that we have also this for zooming. Okay, and the next thing is what if you are adding bookmark, this is for selecting nothing, this is for free from selection. We just want to just select free like this. Means like if you have a network which is not symmetric, and if you just want to select only few network and just um, uh, move to any other place, this option is very much helpful. That is free from selection. Just you can select any type, whatever, how the cursor you will move, how you will move the cursor of the mouse, how you drag, accordingly it will get selected. Like in this region there are 2 buses, so those 2 buses will get selected. Like in this I have drawn like this, so only one gets selected. So this is the option of free from selection. After that, already told about the resizing of the drawing window. Here this is the drawing format for A4, these all things, various option available. Okay, so we have 3 bus bars. The next thing is just introduce again the same. These are the various equipments. Introduce another grid. As I have selected grid, now grid is selected. So for introducing any grid, you can just place grid anywhere. Like I have just placing grid and clicking first time on grid here, and after that I just second click here and just third click to here. So the grid is connected. There is nothing, no hard and fast that you just place grid here only. You can place anywhere. So, and for deleting any equipment, just click on left click on any and just go to delete 3. Okay, and so let's choose the this grid and drop here. And the same, I have already drawn this network, but this time I'm just going by more elaborate way. So just as you are working on your PC, so just as I'm doing, just copy that, and you will get the better idea that how to design your network. And after that, introduce this two winding transformer and select this two winding transformer. This is selected, that's why it is with the cursor, and just click on this and drop this and drag it. Just first click on the bus and just then second click on this terminal, like right now. Delete this. Delete, yes, and select this. And if you would just want to add transformer between bus 1 and bus 3, how will you do? We will click here, we will click here, we will click. Okay, so it is connected between bus 2 and 3. So what we have to just do is just click on any bus and just drag to the bus till which you just want to connect your transformer. So just click on this and drag to this, again connected, or that again the same with the line, there is nothing new in this when hands-on, but the thing is, while you are doing, so just do step by step that how, and after that you will learn. And deselect this and one load also. So okay, after that already told about how to just make the network elements smaller. So for that, just click on this, as the this grid is selected because it is having this select blue color, so it shows it is selected. Click on this, and after that drag downward. Click on the mouse. When this cursor will appear, it means you can drag now. So just drag here. See the network reduced. When you just want to decrease the size of the transformer, you can't decrease the size of the transformer, but you can decrease the spacing between the two buses, and you can do it by just clicking on this and just going more near to the bus 1. With that, the transformer size will reduce, and same with this. Okay, so this was all, and after that, what the thing is which we are going to do is, after designing the network, the next thing that comes is adding the values or editing the properties of these various equipments. Properties means for which they will are valid for editing. Means buses are valid for voltages, and transformers are valid for MVA values, and high voltage, low voltage values, all those things. So as we see here, it is 1 and 10 kilovolt, that is default. So for grid, there's nothing to change because it already takes the value that 1 and 10 kilovolts, or the value that on which the grid is connected from the bus. So we will starting from this terminal, make it more. Okay, so starting from the terminal, two left clicks on a terminal will open the terminal properties. In the terminal properties, I've already told these are the various options available, like for system types, usage, bus bar, phase technologies, nominal voltage, line to ground. These all things are available. So what you can also edit from new project type. the bus bar type is this, but it is more preferred to use from here, because from on editing the value from here, you can just on the first click, when you will click the first on this bus bar, you got to know about the line to line voltage. So just the default is 110 kilovolts, leave it as it is, and after that ABC, whatever you want, just select. And what are the usage of the bus bars? Oh, and the load flow, the same things that I've already shown you in my presentation. And these changing the name really helps while drawing the graph, because sometimes the terminal 1, 2, 3 doesn't show up in while designing the graph. So it's better to have very clear name of bus 1. So this is bus 1. In the bus we have just edited the line to line voltage, so which is already at default value of 110 kilovolts. Okay, and next thing is for a transformer, this is two winding transformer. These are the cubicles, these are called as cubicles. These cubicles, the values that are for which they are calculated comes in that. And of that, select, when you will select any equipment, it will turn into blue, and double click on that, it will open the properties of that equipment. Same way it has zone, area, all those things. And in the type also, again, there is new project type, the same thing already shown you, that rated power, whatever you think, because you are already the faculties of power system, so whatever you think, just edit those value. I am just going with 25 MVA, and mm, uh, high voltage is 110, and low voltage that I'm considering is 11. And you can also, if you have any practical example of any network having 3 buses in the transformer, and what if you want to just introduce the positive sequence impedance, just edit those values and see whatever the difference that I am having, and what are the difference between the result that I am having and you are having. So you can add those values for positive impedance, short circuit voltages, copper losses. These all things you can reduce. You can also reduce the phase shift, yeah, just by clicking anything. But for now, I haven't this all data for all this. So it is yn 0, and the vector groups can also be changed. Okay, the load flow. These are like magnetism, impedance, no load losses, or R by X ratios. There's various options available, so you can change if you think so there is a need of. uh, okay, click OK. Then again to the bus 2, go with the bus 2, have the enter the voltage as line to line value as 11 kilovolts. System type is AC, phase technology is ABC, bus bar, what are the usage of the bus bar, and again the load flow, all those things. Those There's option already shown you. These are the various options for the global types already shown you. So for importing the global types, click on that, and okay. So right now I've just imported the global types, but as we are drawing our own network, so just go to new project type, and add and write as 11 kilovolts. Okay. Now after the line, length of the line, let it as a 10 kilometers, lumped parameter distributed. You can have that also. What is that? There's nothing in this. Or that, click on the auto service. You can click number of L line, also can be the rating factor, whether it is in ground or air. Thermal ratings. Right now there is no library of thermal ratings, but we can import that also. And in type, global type,
These are the various global types for the line. 10 like if we choose for 60 kilovolts, in 60 kilovolts, see only copper is valid. There is I have shown in presentation the two of the elements, copper and aluminum was there, but in the 60 volt, copper is only there. Like in 30 volt, yeah, see, aluminum copper is there. So it is preloaded globally. All the data that are used globally are given here, so you can edit those also. But for now, we are having our project. So edit line 1, rated voltage is 11. um, Cable system type, add 6 4 5 4 5 3 4. Add any random value whatever you need, and just in the load flow also you can also add the change the conductive material, that is solid aluminum, aluminum steel, this all those things, basic data. Go to OK, click OK. Go to this terminal, connection to sim not allowed. After that, the last bus is also at 110 kilovolt. Click OK. And after that, the general load. In general load, what we have to do is, when it comes to general load, what we have to do is double click on it and click on the type, click on the project type. There is nothing to edit the values, but there is options of various, like what are the system types, AC or DC, and what are the different technologies for the loads, that is three-phase delta, three-phase 5, YA, and various of it. So the default is three-phase delta that is selected. So I'm just going with that and click, but just have confirmed that it is selected or not, and click on OK. And after that, go to load flow, and if whatever the data you have, means if you have a active reactive power, all there are the collection of various options. Whatever you choose, you can just go with that. And after that, just have that active power and reactive power. So I have 4 and 2 5 2 3, and click on OK. So as we have edited the for all the values, like from, let me send to 75%. I have edited for the all values, like starting from the bus 1, bus 2, and let me change the name for this also, bus 3. So the things are very simple. Just first thing is just drag and drop, design a network, anything. Like if we just want to design any 14 bus system, what we are just going to do, just have that 14 bus system in your PDF or anything. Just draw that network, connect the various elements together. If you have data, all the buses, all the transformers, all the loads, just edit those values. And the next thing is just calculate the load flow. So as I'm showing for the 3 bus, the same method, the process is same for designing for either 9 bus or 14 bus, 39 bus, or 118 bus, or any kind of system. You can just go first, design, drop, and connect with the various elements. Connect the 2 buses with transmission lines or from transformers or anything. And after that, the next thing is just execute whichever analysis you want to just perform. And because there is a various lots of analysis, but and we can do all kinds of analysis with this. But as I'm showing only the short circuit and load flow, but you can learn more and more by either from the examples, videos, or from the user manual. So the very next thing is how to just import the virtual instrument panel to this. So the next thing is what we have to do is insert virtual instrument panel. When on clicking this, it is asked about which how many types of VI. You can change the number of VIs. Like if we have the network of like if I'm designing for the 14 bus, and if one just compare that what are the voltage levels for generator 1, 2, 3, and for the 3, 4, like these things, we will introduce the number of this 2. So there will on this virtual instrument panel there will be two small graph section. So the comparison will be more better. So this option is for that, and I already shown the various types of plots available here at subplot from starting from bar diagram, vertical experimental scale, path diagram, distortion analysis, curve input, digital display, or various things available here. But the first thing is uh, going from the very beginning. So choose for the subplot. As a subplot will gets introduced, the next thing is what you have to is to define the power system elements. So defining the power system elements is needed because see here there is no, as I was showing the presentation, but when you will define the those components will show with their appropriate colors, that but here it is total blank. It means there is no element has been defined yet. So what we will be defining is to winding transformer. Click on to winding transformer, it will turn into blue. Go to define and go to result for RMS CMD simulation. Click on that, and this box will open. So as this box will open, the next thing which you want to do is that we want the loading curve for this two winding transformer. So we will click on here. On just going there is the option. It is showing that variable selection. So when you will double left click there, the box will open for variable selection study case. And that there is a lots of options like for the variable set available, like current, voltage, bars, bus results, signals, calculation parameter, LM parameter, type parameter, reference parameters. So go to the calculation parameter and choose loading for two winding transformer and click on OK. As I already shown you on the presentation, but for when you will just do it by yourself, things will get more clear to you. So I have very selected the loading for two winding transformer and just close this. Next, what we could choose is this bus, and we just want to see the bus voltage in PU. So on defining the bus for RMS simulation, the bus 3 will come, and again the same method. Double click on the here play button, double click there, and choose for voltage, magnitude, and P already been selected U1. So this OK. Click on OK and close this. And we can also choose this line also. Again the define, go to the line is there, go with the line, and go to calculation parameter, and where is calculation parameter, and search for the loading. Where is the loading? um, Here it is, loading, and click on loading. Okay, and let's have this bus also define for this also. Bus 1, bus 3, line, And okay, as not for as I have already selected the variable and defined the various element. The next thing is to close this window. The next thing is go to virtual instrument panel. When you will come to virtual instrument panel, here we can see it's not showing all those equipments. The next thing is we have to just mention once again we just want to see the various curves of all those defined equipments. So for that, click anywhere. Click anywhere on this VI, double left click, and this window will open. So it is asking about what are the elements, what are the variables, and color, style, width, all those things. First thing is this is the curve for designing a subplot. The first thing is result file. So double click on this and go to summary grid and go to all calculation. Okay, and after that start introducing the element. Double click on this and two winding transformer. Okay, insert row, double click all calculation, line, again insert row, all calculation, element is bus 1, and the last one is all calculation, element is bus 3. I mentioned all the elements with a subplot. The next thing is to introduce the variable that I have already selected while defining. So next thing is double click on the variable, and I will double click what you have defined that comes here. So I have chosen for this voltage magnitude defined, same with the bus 1 defined, line I have chosen as for loading, and for the 2-end transformer loading. So till here things are very simple, there is nothing to do. You can also change the color for this. So let me leave it as it is. What you want to see, the various styles. So you just want to differentiate that these are for that. So let me change the style. For the bus 1 I just want this one. For the bus 1 on this, for the line I want this, and for the 2-winding transformer I want this. Width, leave it as it is. Okay, see here the design that I've chosen, they are showing according to that. So it is now mentioned. The next thing what you have to do is make sure that RMS EMT simulation has been selected, because as you will choose the any different value, like I'm going to select for the quasi dynamic simulation, the whole icons will change. Means there is no option of plotting the graph. It will, this is option of running the quasi dynamic simulations. But as we are going for the with the load flow, make sure that we have selected the RMS EMT simulation. So select RMS EMT simulation, selected. Next thing what we have to do is choose the RMS value. I will choose the instantaneous value later. Choose the RMS value, electromagnetic transients for, and click on execute. This is executed. The next thing which we have to do is we to just start the simulation. So in the start the simulation, just have some any time, 5 seconds, and execute. It is only showing one graph only, because all those values like for bus voltage, PU, line loading, and 2-end transformer have all the graphs are above this value. So what we have to do is we have to just adjust the graph. See, before it was the graph was only till 1 PU. That's why the brown color was here, and all those for the bus voltage and line loading, all those was above this. So with this you can just scale y-axis automatically. Just click on this option and it will scale the y axis automatically and will show you all the diagrams, all the various network or the line loading of these graphs on a single VI, virtual instrument panel. Okay, so as I have selected for the bus voltage this type, and for the line in PU I was choosing this plane, and for the 200 transformer I have used this way of showing the graph, and for the green I have chosen this. So it is showing in that way only. We can also see this by option of, there is option of, this is the I selected for the curves. We can also see this by bars. So these are the bars, but for now just I have to curve. Okay, so this was the virtual instrument panel. What, let's have instantaneous value and check what happens with this graph. Execute and again scale it. The instantaneous values are only valid for a voltage phasor, that is for bus and bus 3 and bus 1. That's why it's showing for 2 only. So as we will change to this, execute, it will only show this on. Okay, and when you will execute this, it will show the loading curves for a transformer and for the line. So this was how to introduce the virtual instrument panel. And the next thing is, the very important thing is how to just import the data to the data manager. What we are just go to the select data and open network model manager. This is very important thing, because we just want to just analyze the data that we are getting from this example, and that again we analyze this. So open network model manager, and the same bus bar, we have 3 bus bars and 2 1 transformer, same, just select and just spreadsheet format, copy with column headers, and just paste on this. Okay, in the same manner you can also import your export your data to from a 2 winding transformer, load type and line type. Like we have 2 winding transformer as this. Okay, and the next very important thing is to how to just see the whole overall summary of the network. So there is one option, this, it's output calculation analysis. Click on this, and there is a various options available, like for after the load flow, that for the bus bars, terminals, total system summary, grid summary, and a complete system report, and all these things. Just click on this, and on clicking it will ask about which kind of report you just want to see. So click on the all and just execute this. Okay, on executing, it will show the overall system summary report that I've already shown in you while presentation. But the process that where how to just do this, I'm going slower and slower. So this is the overall system summary report, and you just want to see the gate map. The options are very in front only, we can see the heat map. The same for the animated load flow, direction arrows, import direction arrows, click OK, go to graphics option, advanced, and animated load flow, and click OK. And after that, just clicking on this, again we have to just perform the load flow and have to execute this. So this will, and I just want, if we just want to stop this animated load flow, click on the escape button. Okay, so after, and next thing is what, if you just want to have this output whole summary report in text file, there is option of also, you can also have this in text file, this option of saving. You can also save this whole system report in text output, and you can see in Notepad or MS Word. So this is option available for this. And I already shown you how to just import the data, any PFD file or anything from downloaded, and means if you have downloaded any PFD file from the internet, if you just want to just analyze those files, just you can import those files over to PowerFactory and just run and just see that what are the various things, various changes you can do. One more thing, like uh, let me reduce one small example, and after that, okay, means as I have, this is 9 bus system, um, and we calculated the load flow for this, but we want to some change in the this whole network. Like if you want to just remove this transformer, we just want to just modify this 9 bus system as according to our need, but there is, as here as we see, there is no library right now here. So how can we do that? So there is nothing, we just go to freeze mode. As the freeze mode is right now enabled, just disable it. When you will see your library, there is nothing, just like this is load is this, just take this and remove this and add load according to you. So this can also be done. If you just want to modify all those preloaded examples according to your need, you can do this also. Okay, and so all things that are needed for designing the network, all those things are here. The MATLAB interfacing are the very important question that are usually asked by every faculty, that how are the MATLAB and all those things are interfacing is possible. So MATLAB interfacing and all those things are possible via two very important features of PowerFactory, that is DPL, that is DIgSILENT programming language, and this DSL, DIgSILENT simulation language. So we could import by using those two. Uh, right now I have no example of that, for that how the MATLAB have been can be interfaced, but I have the few examples that I have downloaded. If you will be in need of that, I will send you to your mail, and we'll also give you the video description that how the PowerFactory and MATLAB can be interfaced. And so this was the end of the hands-on session. If you have any query regarding anything, the various types of analysis, because as I have only shown you the short circuit and load flow, but if you have any, if you are working on any particular analysis like time dynamic simulation or regarding all such things, and you have any query regarding that, just send me mail. Uh, I will work upon that and will answer you. So this was the end of hands-on session. So if you have any query regarding the whole Power Factory and all those things, please send me over to me from chat boxes. Audio is very unclear. Okay. Sir, if you have any queries, sir, please tell me. If not, sir, I will be ending this today's session of this faculty relevant program. Okay, sir. Sir, I have already sent you the hands-out manual. That what I have done in this hands-on manual, I have written. Okay, sir. I have written all those steps by step in hands-on manual. You can just refer hands-on manual for if you have any query. And
हो गया था फिर एंड करें इसको क्या सर कभी भेज दीजिए सर जब भेज देंगे उसके बाद सर्टिफिकेट आपको जनरेट करके भेज देंगे मेल पे आपको एक्सेल फॉर्मेट में जितने लोगों ने अटेंड किया है ना सबकी डिटेल्स एक्सेल में जो हमने भेजा हुआ मेल आपको उसकी फॉर्मेट में सारा वो डिटेल और अटेंडेंस किसी ने अटेंड किया है और फोटो वगैरह कुछ भी आप मुझे भेज दीजिए अच्छा ठीक है बाकी वो प्रपोजल मैंने कल भेज दिया था आपको मिल गया था सर हाँ वो जो भी प्रोसीजर होगा आप देख लीजिएगा मैंने अपना ऑफिशियल प्रपोजल आपको भेज दिया है जो प्रोसीजर होगा वैसे आप फॉलो कर लीजिएगा ठीक है सर तो देखिए इसको अगर आता है बजट में तो देखिए परचेज करके सॉफ्टवेयर का तो आइडिया लग ही गया होगा आपको हैंड्स ऑन करके और देख के प्रेजेंटेशन तो प्रेजेंटेशन ठीक है सर ठीक है देखिए इसको फिर आगे ओके सर थैंक यू